Welcome back to the deep dive. I want to start today by looking at the architecture of our daily lives.
Okay.
Not the physical buildings, I mean, but the mental architecture.
Sure.
Think about how you navigated the last hour.
Mm.
You walked into a room, you flipped a switch, light is on. You finished a task, you closed your laptop, work is off.
We are absolutely obsessed with binary states.
Totally.
How we organize chaos, right? It's just efficient.
Hmm.
If we didn't categorize things as active or inactive or safe or dangerous, we'd be paralyzed by all the sensory input.
We love a good toggle switch.
We do.
It's clean, it's digital, but today we're looking at a set of arguments that suggests this. This comfort zone is actually blinding us to how the physical universe really works.
Ah.
We're diving into the continuity of universal force, and the central thesis here is pretty radical in its simplicity. It's arguing that the whole switch mentality is just flawed.
Fundamentally flawed when applied to nature.
Right.
It's the difference between the map and the territory.
Explain that.
We've built a digital map. Our computers, our logic, our on-off switches. But we're trying to use it to navigate a territory that is fundamentally analog.
And the argument is that nature doesn't have switches?
It doesn't do steps. It does flows.
So to get our heads around this, we have to unlearn some things.
We do.
Specifically, we need to talk about gravity, because that's the main example they use here.
Right.
Now, usually when I think about gravity, I think of it as something that, well, that acts. I knock my coffee mug off the table, gravity activates, and the mug smashes.
And if it's sitting on the table,
Then gravity feels inactive. It's done its job. It's off.
that's the intuitive view, sure.
Yeah.
But that's looking at the effect, not the cause. The source material makes a crucial distinction here.
Okay.
It says gravity isn't a mechanism that turns on or off. It's a continuous influence.
Okay, but playing devil's advocate here, if the mug isn't falling, isn't the influence basically zero? I mean, functionally, for me, nothing's happening.
Is it, though? Think about the physics of that mug on the table. It's not that gravity just stopped pulling.
Right.
Gravity's pulling just as hard as it was when the mug was falling. The difference is that the table is pushing back with an equal and opposite force.
So the stillness isn't an absence of force.
It's a deadlock of forces. It's a high-tension equilibrium.
So nothing is ever actually at rest in the sense of being, disconnected from the force.
Exactly. And that's the pivot point. The text argues we need to stop looking for discrete states like falling versus sitting and start thinking in terms of functions.
Functions. Okay, now, for our listeners who might be having flashbacks to high school calculus,
Right.
or maybe just shut down at the mention of math, let's clarify. We aren't asking anyone to solve for x here.
No. But the concept of a function is vital. It really is.
How so?
Well, in the early days of math, we had algebra, which is great for finding specific numbers. X equals 5. It's static. But when we tried to describe planetary motion or falling objects, algebra wasn't enough.
It couldn't describe the change.
Exactly. We needed calculus. We needed a way to describe smooth changes across a range of intensities. That's a function. It's not a staircase where you jump from step 1 to step 2.
It's a ramp.
It's a ramp.
That's a great visualization, because on a staircase, you're either on step 1 or step 2. You can't be on step 1.5.
But on a ramp, you could be at any infinite point along that curve.
Precisely. And the argument this deep dive presents is that everything in nature is a ramp.
Everything. The text explicitly states that outside of engineered digital systems, nothing in nature truly works in binary steps.
That's a huge claim. Nothing in nature. I'm trying to poke holes in this. What about quantum mechanics?
Good question.
Isn't the whole point of a quantum leap that an electron is here and then suddenly it's there without traveling the space in between? That sounds pretty binary to me.
That's a fantastic counterpoint. And you're right. At the subatomic quantum level, things do get jagged. You have discrete energy packets.
So it's not a ramp down there.
Not in the same way. But the material we're looking at today focuses on universal force, macrophysics, gravity, electromagnetism, the stuff we interact with daily.
Our world.
In that world, the world of falling apples and planetary orbits, there are no quantum leaps. You don't teleport from your driveway to the highway. You accelerate.
You pass through every single fractional speed between 0 and 60.
Every single one.
So the digital world is literally a human invention.
It is. We created the binary. We
Yeah.
built logic gates 0 and 1 because they're robust. They don't degrade. A signal is either there or it isn't.
But nature doesn't care about our need for clean signals.
Nature operates on a dimmer switch, not a toggle.
Let's stick with that dimmer switch image because the text gets into the specifics of how this dimmer works. It says physical systems are always active to some degree,
Always active.
which again feels exhausting. But it brings up this idea that what changes isn't whether a system is on, but how strongly it acts.
Right, the intensity.
And it lists 3 specific variables that control this intensity: pressure, mass, and energy.
The 3 dials on the dashboard of the universe.
Let's break these down because I feel like this is where the theory actually hits the road. Let's start with pressure. How does that fit into this analog worldview?
Okay, well, think about the air around us right now. We tend to think, oh, I'm in a room with air, or I'm in a vacuum.
Binary, air or no air.
But physically, that's nonsense. Atmospheric pressure is a gradient. If you go to the bottom of the ocean, the pressure is immense. If you go to the top of Everest, it's thin.
There's no sudden line where the atmosphere just stops.
It just fades.
Mathematically.
It follows a curve. Even in what we call the vacuum of space, there are stray molecules. There's a tiny infinitesimal pressure. It never actually hits zero.
So you can't flip a switch and say pressure off.
You can only slide the fader down to a very, very low setting.
So when we talk about a vacuum in a lab, we're just bragging about how low we got the dimmer switch.
That's it. We're saying, look how far down the curve we push this function. But we haven't escaped the function. We're still on the graph.
Okay, let's move to the second variable, mass. This one seems, intuitively linked to gravity. More mass, more gravity.
Right. But let's nuance that. We usually think of mass as a thing. A rock has mass. A feather has mass.
But in this context,
In this context, mass is a condition that distorts the field around it. It's not just sitting there.
it's active.
Always. Every object with mass is exerting a gravitational pull on every other object. Right now, you are exerting a gravitational pull on the microphone in front of you.
Really?
It's just that your mass is so small compared to the Earth's mass that the Earth wins. But your gravity isn't off.
That's a weird thought. I'm gravitationally attracting this coffee mug.
You are. And the moon. And the Andromeda Galaxy.
Oh.
The intensity of that attraction drops off with distance. That's the function part, the inverse square law. But it never, ever reaches true zero.
The math doesn't allow it.
The curve gets closer and closer to the bottom line, but it never touches. So in a very real sense, you are touching everything in the universe with a tiny bit of force.
Okay, that's big. We'll come back to the philosophical side of that. But I want to hit the third variable, energy.
The big one.
The text mentions energy as the driver of intensity. But again, we think of energy as I have energy, or I'm tired, the battery is charged, or the battery is dead.
A dead battery is the ultimate off state, right?
Right.
Is it, though? Think about a battery sitting on a shelf. Is it inert? No. It's a chemical system in a state of high tension. The electrons want to move from the anode to the cathode.
They're vibrating with potential.
The force is there, fully active, screaming to be released. The only reason it looks off is because the resistance is too high, the air gap between the terminals.
So a dead battery isn't devoid of physics?
No, a drained battery has just reached equilibrium. But even then, the atoms are vibrating. There is thermal energy. There is mass energy.
If you heat that dead battery up.
It explodes. Why? Because the energy state changes. It moves along the curve. It never creates a situation where energy just vanishes. It transforms. It dissipates.
It's a flow.
It's a flow.
This reminds me of that law of thermodynamics: energy can't be created or destroyed.
Exactly. It just changes, guys. And because it can't be destroyed, the system can never truly turn off. It can only change from, say, useful concentrated energy
A charged battery.
to disordered spread out energy, like heat. But the hum of the universe never stops.
So if we take these 3 together, pressure, mass, energy, we get a picture of a universe that is just a constant shifting sea of intensities.
That's the analog reality.
Which brings us to the so what? Because this is fascinating physics, but how does it change how we actually perceive the world?
Well, the text argues that once you see this, you can't unsee it. It changes your perception of stillness.
Yeah.
It forces you to look at silence differently. Think about a city. You might say a city is quiet at 3 a.m. But is it?
No. There's the hum of electricity in the wires, the distant rumble of a truck.
The wind. Quiet is just a relative term for less noise than noon.
Right. And the text argues that the physical universe is just like that city.
Exactly. When we see a rock sitting still, or deep space, or a quiet room, we are just looking at a low-intensity section of the wave.
Yeah.
We aren't looking at a flat line.
It makes the world feel much more alive, or at least dynamic.
It does.
If I look at a bridge now, I don't just see a static object. I see a structure under constant stress, balancing gravity, wind pressure, thermal expansion. It's doing a lot of work just to stand there.
It is active to some degree, as the text says. And this has implications for how we solve problems, too.
How so?
If you think in switches, you look for the one thing that broke. We'll flip the switch. But if you think in functions, you look for the accumulation of factors.
How did all these things interact to push the system past a threshold?
Thresholds, that's a great word for it. In an analog world, events like a bridge collapsing aren't random glitches. They are just the moment the curve crossed a line, the buildup was happening the whole time.
This connects back to what you said earlier about me interacting with the Andromeda galaxy.
It does.
If everything is analog and everything is a continuous influence, then isn't everything interconnected?
Invariably. A switch isolates. If I turn off the light in this room, it's optically disconnected from the hallway. But if gravity is a continuous field, there is no isolation.
Just varying degrees of connection.
Yes.
Mm.
The universal force described here implies a seamless web. If you wiggle your finger, the gravitational field of Earth shifts by an infinitesimal amount.
Which shifts the moon's orbit by an even smaller amount.
And theoretically, that ripple goes on forever. It gets lost in the noise, sure, but the math says the influence is there.
That's the butterfly effect, basically.
It is, but applied to basic forces. It means we aren't just objects bouncing around in a box. We are thickenings in the field. We're just local spikes in intensity.
Local spikes in intensity. I like that. It makes me feel very significant and very insignificant at the same time.
That's usually a sign you're close to the truth.
So we've dismantled the switch. We've established that nature is a dimmer, not a toggle. We've looked at the variables, pressure, mass, energy. But I want to go back to something you hinted at, the idea of zero. Because if the curve gets closer and closer to the bottom but never touches it,
It never does.
and if gravity extends forever and energy can't be destroyed, then does zero actually exist in the physical world?
This is the provocative question the source leaves us with. We have a symbol for zero. We use it in math. But can you point to zero in the real world?
I mean, I have 0 apples in my hand right now.
Do you? You have air. You have dust. You have light photons passing through your hand, neutrinos from the sun blasting through your palm.
Okay.
In terms of apples, sure, you have a null set. But in terms of physical reality, your hand is full of activity.
Fair point. But what about absolute zero, negative 273.15 degrees Celsius, the point where all motion stops?
A theoretical limit. We can get very, very close to it in a lab. But we can't actually reach it. Because to reach it, you'd have to remove all energy. But the system itself has mass, and mass is energy. And there are quantum fluctuations.
You can't strip the universe naked.
There's always a hum.
So zero is a concept. It's a tool we invented, just like the off switch.
Precisely. It's a useful fiction. It helps us balance our checkbooks and write code. But the universe doesn't know what zero is.
The universe only knows something.
Sometimes a lot of something, sometimes a little something. But always something.
That is haunting. In a good way, it means the story never stops. The signal never truly cuts out.
It suggests an eternal continuity, which, if you think about it, is much more awe-inspiring than a universe that just clicks on and off like a cheap flashlight.
It really is. It changes the way I'm looking at everything in this studio right now. The table, the walls, even the silence between us, it's all just vibrating.
Waiting for a change in conditions. Waiting for a change in pressure or mass or energy to ramp up the intensity.
So, listener, that is your mission for today. Step out of your digital binary on-off brain for a few minutes. Look at the world as a function. Look at the continuous flows. And try to find something that is truly off.
I bet you can't.
And if you think you found it, look closer.
You just aren't seeing the curve.
Thanks for deep diving with us into the analog nature of reality. It's been a heavy one, but hopefully it shifted your gravity a little bit. We'll catch you on the next wave.
What are you thinking?